We are now at 9.1, and this section, as you see, is called Testing the Difference Between Two Parameters. If you don't already have your formula card, calculator, ebook, textbook, paper, pen, sticky notes, index cards, whatever you need for this section, make sure you hit pause, go grab all your tools, and then come back. I'm pretty much going to read this whole little section to you. You could read it on your own, but I'm going to go ahead and record the reading. It does start here, and it says, suppose a researcher wishes to determine whether there is a difference in the average age of nursing students who enroll in a nursing program at a community college and those who enroll in a nursing program at a university. In this case, the researcher is not interested in the average age of all beginning nursing students. Instead, he's interested in comparing the means of the two groups. Comparing the means of the two groups. His research question is, does the mean age of nursing students who enroll at a community college differ from the mean age of nursing students who enroll at a university? And here the hypotheses are. We just came out of Chapter 8. We just finished hypothesis testing. So keep in mind everything we just looked at there. Apply it here. See the subtle difference that now we're going to be comparing the means of two groups. And then notice here we still have a null hypothesis, but look, it's doing the mu of one equals the mu of the other. I want to flip back pretty fast and look where we've been. We were just looking at the mu, can't see it, that the null hypothesis was the mu was some number, and then the alternative hypothesis, well, it was the mu is not that number. We always had the null as the equals, and we always had the alternative to be not equal, greater than, less than, and then that started determining our left tail, our right tail, and our two tail. So notice here, this looks very similar. We're just comparing means and not just saying one is worth a certain value. And so they're either equal. Again, all of our null hypotheses are going to be the equals. And then the alternative, the alternate hypothesis, is going to be something else. They go ahead and mention a little bit more about this mu sub 1. They're designating. That's going to be what's going on at the community college. And mu sub 2, that's going to be the mean for the university. And then this is critical. Make sure you see this and pause the video and think on this, that if we took this mu sub 1 equal mu sub 2, throw down a little bit of algebra here, that if we subtract mu sub 2 from both sides, we get mu sub 1 minus mu sub 2 on this side, and over here we're left with 0. And look, that's all they're trying to tell us, is that another way to look at this, and that's why it says another way, is that the difference of the means is 0. There is no difference. They are truly equal. If one is 80, then the other is 80, and 80 minus 80 is 0. They really are the same. That's our null hypothesis. But this is saying in the alternate that nope, when you subtract them, it doesn't equal 0. There really is a difference. There really is going to be some kind of number there. If there is no difference in population means, subtracting them will give a difference of 0. See? If they are different, subtracting will give a number other than 0. Both methods, up here and here, of stating hypotheses are correct. However, the first method is going to be used, this one, in our text. When testing the difference between two proportions, the same reasoning applies as testing the difference between the two means, and it's going to mention one here, and then we're going to jump up here, because I don't want to read every word to you, and I'm on page 418, and I'm at the top of that page, and that's not an 18, that's a 481, I'm going to ask you to focus one more time, and it says the hypotheses would be, from what I didn't read over there, is that the null is that the proportions are equal, and the alternate would be that they are not equal, where P sub 1 is the percentage of the male workers working more than 5 days a week, and P sub 2 is the number of male workers who work female workers who work more than 5 days a week. And again, we could write this, we could move that P sub 2 over, P sub 2 over, and we would get P sub 1 minus P sub 2 as we see here, and when we subtract these we would get 0. Again, another way to say it, but we're going to be writing it the first way for our book. The previous two examples show the hypotheses for two-tailed test. When it's not equal, that means it could be some over here and some over there. But if you're using a right tail, then it's going to be this, because then you're saying one of the means is actually greater than the other mean. For two proportions, they're just saying, okay, this is what it looks like for means, this is what it looks like for portions on the right tail because it's greater than, greater than. If you're using a left-tailed test for the means, then it's going to be less than. It's going to put the left tail over where it belongs, and then proportions will be the same. If two samples are independent of each other, big word, the subjects selected for the first sample in no way influence the subjects who are selected in the second one. For example, if you got a group of 50 people randomly divided into two groups of 25 people each in order to test the effectiveness of a new drug, where one group gets the drug and the other group gets a placebo, then these samples are independent. And I know we've played around with the word independent this semester, feels like a year, maybe 2 years. Then they are independent of each other. On the other hand, two samples are going to be called dependent if the selection of subjects for the first some way has influenced the selection of the others. For example, suppose you want to determine if a person's right foot was slightly larger than his or her left. In this case, the samples are dependent because once you select their right foot, you gotta select their same left foot. It is dependent on the right foot you choose. So the theory behind testing the difference between two means is based on selecting pairs of samples and comparing the means of the pairs. The population means need not be known. All possible pairs of samples are taken from the populations, and the means of each pair of samples are computed and then subtracted, and the differences are plotted. If both populations have the same mean, then most of the differences will be 0 or close to 0. Don't y'all just love it when they say, yes, do it this way? Well, it's kind of right. Well, not really. Occasionally, there will be a few large differences due to chance alone, and that's a whole other topic. So some positive and some negative. If the differences are plotted, the curve will be shaped like a normal distribution and have a mean of 0. If in the comparison of two sample means, the difference may be due to chance, in which case the null hypothesis will not be rejected, and the researcher can assume that the means of the population are basically the same. The difference in this case is not significant. On the other hand, if the difference is significant, go down to page 482 right here, it's going to be rejected and the researcher can conclude that the population means are different. I'm not fond of, we've got 3 different drawings here, not fond of any of them. I do want to read part of it. The difference is not significant. The means of the population are the same. And so we're not going to reject because we're saying that the mu's are the same, and since they're different, it's not really significant. And that's that picture and what it's supposed to be symbolizing. However, if you have these two, and they're stating the difference is significant, the means of the populations are different. In other words, they're not equal, and then this difference is going to be significant. The same reasoning goes for the difference between two proportions. The general formula for testing the difference between two means or testing the difference between two proportions is, we're going to have a test value. That's what we did in Chapter 8. We're going to have an observed value. That's been a cute little number minus a cute little number over another cute little number and maybe a square root of a couple of cute numbers. And even trying to write this, I couldn't even write it, and I smeared it and used whiteout. What we're going to do is going to be just a little uglier than that. But the formula is on your formula card, so no need to worry. The values for this formula are shown in the following sections. 9.1 and 9.2 homework are combined, so that's all you do for 9.2. You go read your directions. Sorry, that's all we're doing for 9.1. Go read your directions for 9.2 and keep going.